Welcome back. Today, we're exploring sets in Python, a versatile and powerful data structure designed to hold unique, unordered elements. Sets are great for scenarios where you need to eliminate duplicates and perform mathematical operations like union and intersection. Let's dive into the fascinating world of sets. Before we jump into sets, let's do a quick recap of tuples. Tuples are immutable sequences used to store multiple items in a fixed order. If you haven't watched our video on tuples, make sure to check it out, and don't forget to look at the description for the quiz answers from the last video. In Python, creating a set is straightforward. Either use curly braces or the set function. What makes sets unique is their ability to automatically remove duplicates, ensuring that only distinct elements are stored. For instance, if we create a set with repeated numbers or strings, Python will filter out the duplicates for us. For example, here you'll notice that even though we added the number 2 and the string apple multiple times, they only appear once in the set. This automatic removal of duplicates makes sets a powerful tool when you need to manage collections of unique data, ensuring efficiency and clarity. One of the most powerful features of sets in Python is their ability to perform mathematical operations like union, intersection, difference, and symmetric difference. These operations allow us to easily compare and manipulate sets of data, making them useful in many real-world scenarios. Let's begin with union, which combines two sets and keeps only unique elements. You can do this with the pipe operator or the union method. For example, if we have, and when we use either pipe or the union method, the result will be. Here, notice how the duplicate 3 appears only once, because sets remove duplicates automatically. Next, let's talk about intersection, which finds common elements between two sets. You can achieve this with the ampersand operator or the intersection method. If we use the same sets as before, this will return 3, because 3 is the only element present in both sets. Now, let's explore the difference operation, which shows what's in one set but not the other. The minus operator or difference method does this. If we do, we'll get 1 and 2, because 1 and 2 are in set A but not in set B. Finally, we have symmetric difference, which highlights the elements unique to each set, excluding any shared items. The caret operator or the symmetric difference method is used for this. The result will be, because these elements are either in set A or set B but not in both. These operations make sets an excellent tool for comparing and analyzing data quickly and efficiently in Python. Whether you're looking for common elements, differences, or unique values, sets have you covered. Sets in Python are dynamic, meaning we can easily add or remove elements at any time. This makes them a versatile tool for managing collections of unique items. To add an element to a set, we use the add method. For example, if we have a set of fruits and we want to add orange to it, we simply use. This will add orange to the set, and since sets don't allow duplicates, trying to add apple again won't change anything. Now, when it comes to removing elements, we have two primary methods, remove and discard. Both allows us to remove items from a set, but there's a slight difference between the two. If we use remove and the element doesn't exist in the set, Python will raise a key error, for example. This will remove banana from the set, but if we try to remove grape, which isn't in the set, we'll get an error. On the other hand, the discard method is safer when you're unsure if an element is in the set. If the element doesn't exist, discard won't raise an error. This method is useful when you want to avoid errors in your code. With these flexible methods, sets allows us to efficiently manage dynamic collections of unique items, whether we're adding new elements or removing outdated ones. Python offers a rich set of methods for working with sets, giving you a lot of flexibility. Let's explore some of the most useful ones. First, we have the update method. This allows us to add multiple elements to an existing set. For instance, if we have a set of vegetables, and want to add spinach and potato, we can use this as a new elements in one go, making it more efficient than adding them one by one. Next, there's the clear method, which removes all elements from a set, leaving it empty, for example. After running this, the vegetable set will be empty. This method is useful when you want to reset or repurpose a set. If you need to create an exact copy of a set, Python offers the copy method. Let's say we have a set of colors. Now, new colors will be an independent copy of the color set. For comparing sets, we have two handy methods, is subset and is superset. These methods are useful when checking relationships between sets. If we have two sets, we can check if small set is a subset of large set using. This will return true, because all elements in small set are also in large set. Conversely, if we want to check if large set contains all elements of small set, we can use is superset. This will also return true, because large set contains all the elements of small set. These built-in methods make working with sets more convenient and powerful, allowing you to perform complex operations with just a few lines of code. Now let's explore another practical use case for sets in Python. Imagine you're handling form submissions from people in different countries, and your task is to extract the unique countries submitted and check which of those are in Europe. Sets make this process simple and efficient. We start with a list of countries submitted via form, and because there might be duplicate entries, we'll convert the list to a set to automatically remove duplicates. When we print unique countries, we'll see that duplicates like France and USA are removed, and we are left with only unique entries. Next, let's create a control list of European countries. We'll use a set for this list as well, and then we'll check which countries from the form are in Europe by performing an intersection of the two sets. By using the ampersand operator, which performs an intersection, we can find the countries that are both in the form submissions and the list of European countries. This approach makes it easy to compare datasets and extract meaningful information. With just a few lines of code, we have been able to efficiently extract unique data and compare it against another dataset. This example demonstrates how sets can simplify tasks that involve data management and comparisons in Python. It's quiz time. Let's see how well you've grasped the concepts of sets in Python with a few quick questions. Ready? Let's go. What happens if you try to add a duplicate value to a set? Which operation will return the intersection of two sets A and B? Which method will you use to add an element to a set? Think you know the answers? Share your responses in the comments below and let's discuss. To sum up, sets are a powerful tool for managing collections of unique, unordered items. They provide efficient ways to perform mathematical operations and manage data without duplicates. This is the last data type that we've covered in this series. As you've seen across the different types, lists, dictionaries, tuples, and sets, there are many ways to manipulate them, using various methods and operators. You don't need to memorize them all. The key is understanding what's possible. Once you know the concept, you can easily search for the exact method or operator when you need it. It's much easier to search for something you know exists but can't recall the name of than for something you didn't know could be done at all. And remember, there's always plenty of information on platforms like W3 Schools if you need a refresher. If you have any doubts, don't hesitate to drop your questions in the comments. Happy coding, and I'll see you in the next dimension.